just going to take a minute to talk about the review guide here. My expectation for this would be for you to look over the concepts that are indicated in the review guide and maybe make some examples or some notes below. You can either do that on a separate sheet of paper or print it off, but either way is fine. So the first one, 3.1, exponential functions, just talking about the form of an exponential. And we know that a cannot be 0, b is positive, and a cannot equal 1. And then the natural base exponential function, which has base e. So base e is where we had f of x equals e to the x. Okay, and of course that's a separate function on your calculator as well. Then we looked at the inverse of the exponential function, which is your logarithm. And your logarithm takes this form, which is just the inverse of b to the y equals x. And so we talked a little bit about going from exponential form to logarithmic form, where we switch the x and y and add the log, or switch the x and y and drop the log, depending on which direction you want to go. We also have the common log, which is log base 10. Normally we don't see the 10 there, however. And then the natural log is log base e, but it's also can be written as natural log. And so you can go back and forth between the two. Lesson 3 had us looking at the properties of logarithms. So we know that if it's in condensed form, we have multiplication, but when we put it in expanded form, that multiplication becomes addition. For the next one, we have quotient. So in the condensed form, with it x divided by y, it becomes subtraction in the expanded form. If we have log base b of x to the p power, the exponent actually on the x part would come down to be a multiplier, so we bring that out to the front. And then for those of you that need to use the change of base formula, we looked at that. You can make the base of the log anything you want to. We typically just do the common log, log of x over log b, because it's easily used in our calculator. And you might want to put some examples of what that looks like in the notes there. In the fourth lesson, we looked at how to take an equation and did exponential equations, where we would take the log of both sides, or if we have a logarithmic equation, we would take the base of both sides. So in that first example there, we've got b to the x equals b to the y. Well, if I have b to the x equals b to the y, b is my base, I would come back and I would take the log base b of both of those. And the result would be x equals y. And then for the logarithmic one, I would really kind of do the opposite and instead of taking the log of both sides, I'm going to put a base on those and say log base b of x equals log base b of y. That's the original problem. Then to get rid of the logs, I'm going to put a base of b on both sides. It's based on whatever's right here. And so that leaves me with x equals y as well, based on the rules in 3.3. And then our last one, using a graphing calculator to write a regression equation. So we had several steps for that. We made, using our graphing calculator, if we're given data, we put that in our list and we edit the list. And we put those values in to usually L sub 1, L sub 2. and then we'll go and we'll pick our regression equation. And it depends, sometimes it's given for us and tells us what kind of equation to use. Sometimes we have to look at the data and figure out what equation to choose. So a suggestion here might be to put the steps for doing a nonlinear regression on your calculator. All right, guys. So I would expect you to look at this review and do the review problems, check your work, and then if you have any questions, please contact me through Canvas or come by my classroom during regular school hours. All right, have a good day.